Okay, section 4.1 is going to be about angles and radian measure. So, first of all, what is an angle? And so in this context, we're going to start with saying that we have a line, for example, that is here, and it's opening up outwards like this. And so the idea is that you have a point here, point B, connecting to point A, and this whole length right here is going to be called an initial side. Okay, and then the other part right here, which is just another line going through 2 points, is what we're going to consider the terminal side. Okay, and so the whole takeaway from this is that there is a measure from the initial side all the way over to the terminal side. Okay, and usually we denote this as theta, right? So that's what an angle is, right? An angle is in between an initial side and a terminal side. Okay, so that's the most general definition, right? Now, if we are talking about this in terms of a more organized way, we look at the x and y coordinate system that we are more familiar with. And so what we have is that our initial side is going to start here on the positive leg of the x-axis. That is our initial side. The vertex, which is here at the center, okay, the vertex is at the center, and then our terminal side is here somewhere in the other quadrants, right? So what we consider the angle is the opening, or how much does it open from the initial side all the way to the terminal side. So if, for example, we have this figure here that goes from the initial side all the way over to the terminal side, then we can say that the angle alpha, and we consider it to be in standard position, is a positive angle measure. Okay, so if it opens counterclockwise, then it's going to be considered positive. And then if we have a similar example like this, where we once again have the initial side and then some terminal side somewhere in the other quadrants, but instead of going counterclockwise towards that direction, if we go clockwise, in the other example, in the left side, if we open counterclockwise, then it's positive measurement. But on the right side, if we open clockwise, then we can call this theta, and then just say theta is a negative angle measure. measure or measurement, right? So those two show us the two examples from starting in the initial side and going to the terminal side, okay? The next part that we have here is classifying angles. So this should be somewhat of a review. And the first example that we have is an angle that opens from the initial side to its terminal side, and it makes an angle that has a measurement, theta, right? In this measurement, the theta is going to be between 0 degrees and it is less than 90 degrees, right? So this is something familiar, and that is going to be an acute angle, right? Anything that has a measurement of less than 90 is going to be considered an acute angle, okay? The other example that we have is if we have an initial side, or an initial side that opens to an angle, and it is equal to 90 degrees, right? If it is exactly 90 degrees, then we have a right angle, or we're going to talk about quarter of a rotation, and then it'll make more sense why refer to it as a quarter rotation later on, but just so you know, it's a right angle, right? Then, what else do we have? What about something that has its initial side opening to something like this, something larger than 90 degrees, right? So here, theta is going to be greater than 90, but less than 180 degrees, right? And so we may know this as an obtuse angle. Then the last example that we have is, well, what if we just have an angle that from its initial position all the way to the terminal position just makes a straight line, or it has an angle that is equal to 180 degrees, right? So this is called a straight angle or half rotation. So whenever we're given a numerical value of an angle and we have to classify, then we're going to put it in one of these four categories, right? If the given theta value is between 0 and 90, then we have an acute angle. If the value is equal to 90 degrees exactly, then we have a right angle. If the theta is given to be between 90 and 180, it's an obtuse angle. And if the angle, or theta, is given to be 180 degrees exactly, then we have a straight angle. All right, the next thing that we're going to talk about is what is a radian, okay? So a radian is just a new way to measure an angle, just like a degree, okay? So something very similar to a degree is just a new way to measure a radian. So let's start with a picture or a graphic, okay, as to what a radian is. So we have a central angle, right, and 2 points that are intercepted inside a circle. So let's go ahead and label a couple things here, right? Here is our vertex, and think of this as 2 points which each ray is intersecting the circle at, right? So remember, this right here is our initial side, and then this up here is our terminal side, okay? So as you know, the center of the circle all the way out to any point really is going to be considered the radius, right? The length of the radius. So in a radian, this distance from one point all the way to the other, and let's see how we can label this pretty good. So this distance here is also the same length as the radius, r. Okay, so the measurement of the angle here, we'll say theta or whatever, is going to be considered 1 radian. Okay, so theta inside of there has the measurement of 1 radian. Okay, so graphically this is what that means. All 3 of the distances or the lengths here are equal to r. So the arc length, which is what I have highlighted there with the dark red color right here, is the same length as the radius. So whatever angle that makes is then considered 1 radian. So let's look at the definition of what is a radian. Okay, so the definition of it is the more technical definition, is that we have 1 radian. Oops, that's kind of too large. 1 radian. Oh boy. All right, 1 radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. Okay, so that is the technical definition of a radian. Okay, radian measure is going to be the new form that we're introducing to measure angles. On the image on the left, we can see that there is an initial side, and if we are to open it up, it finishes on the terminal side, and then here is the length r, right? And so this little tick mark tells us that this first part is 1 measurement of the length r, and then there's another measurement of the length r. So we're saying that the central angle beta is then going to be equal to 2 measurements of the radian. So B is equal to, not B, but beta is equal to 2 radians. Okay? On the picture on the right side, we can say here another measurement of R. Here is R, and R, right? Therefore, if I open this central angle from the initial side to the terminal side, and we'll call that something like a rho or a gamma, we can say that gamma is equal to 3 measurements of radians, or 3 radians. Okay, so it's simple as that, as being able to count how many times with respect to the length of the radius has it opened and in which direction, right? So to finish up the radian measure, okay, we want to say consider an arc of length S on a circle which has radius R. Now the measure of the central angle and we'll call that central angle theta that intersects the arc is the following. So theta is equals to S divided by R, and is going to have units of radians. So the image that goes with it is going to be the following. Okay, so we'll have something like this where theta is this central angle, this is the radius, and then we'll have this arc length, right, from initial side to terminal side is known as S, the arc length. So theta is our central angle and is found by dividing the arc length by the measurement or the length of the radius. Okay, to convert between degrees and radians, since we started to talk about degrees and then introduced a new form to measure angles, which is radians, let's consider the following scenario. We have a circle and it has a radius here. Okay, we see the red part, and that is the arc length. Okay, and so the arc length is going to be considered 2 pi r, right? Why is that? Well, the distance around a circle completely is also known as the circumference. Okay, so if we go around one full rotation, right, like it's shown here that you start out from the terminal side and then go around and then end up on the same terminal side. Well, my terminal side and initial side are the same, is what I'm saying. You go around one full rotation around the circle and end up in the same place. Well, we have the arc length be equals to 2 pi r. If you assume that the radius is equals to 1, then one full rotation is equals to 2 pi, okay? So keep that in mind. And since we know what one full rotation is, is equals to 2 pi, then we can say half rotation, or half the circle, is then going to be pi radians. So let's connect the things that we know. We know degrees very well, right? Because that's what everyone grows up using. Degrees, a full circle is 360, half a circle is going to be 180. So with that idea in mind, let's kind of write that down. So a full rotation is 360 degrees, and that equals to 2 pi radians, right? Then, well, half of it is 180, which we know, and we say that that's pi radians. Conversion between degrees and radians is going to go as follows. So, if you are going from degrees to radians, meaning if you have degrees and you want your answer to be in radians, right? So you'll do the following. Multiply by pi radians over 180 degrees, okay? Then if you're going from radians to degrees, then multiply by the reciprocal of what's above, right? So 180 degrees over pi radians, right? So the tip is that the unit that you're converting to appears in the numerator of the conversion factor, right? So if you want radians, like right here, then you're going to have radians on the numerator, right? But if you want your units to be in degrees, then make sure you put the degree units on the numerator. And that's how you convert from degrees to radians and from radians to degrees. All right, now we want to look at kind of the introduction of what we call the unit circle. So think about the figure that we have here. So here's the vertex, and here is the circle. So think about the different angles that are in here. So if we talk about from here to there, right? If my point was here and it was to travel upwards, right? So what is that angle? What if it goes from here to here? What is the angle there? From here to here, and so on. So the idea is that we're going to talk about what is the angle from one of those points, right, from the initial side. So if we talk about our initial side being here, right, and it's opening upwards to one of those terminal sides. So we want to keep in mind what we talked about earlier and only focus on the numerator or the top part of the circle here. So this part right here is what I'm going to kind of consider at the beginning. So how many pieces, once I draw these lines, or once you kind of consider these lines being drawn, you notice that on the top half there is 1, 2, 3, 4 sections, right? So we'll just kind of go with this mentality here. And we're going to consider that only for now. So here is 0 or 360 degrees, right? If you were to go around the whole circle, one revolution or one full go around of the circle, it's 360 degrees, right? That's what we talked about before, but we want to rewrite it here in terms of radians, right? So we say that 0 radians, it's 0 degrees. But we talked about the circumference of the circle being 2 pi r, and if we let the radius be 1, then this is 2 pi, right? Either doing nothing or then going around the whole circle one full revolution, right? This, consequentially, then it's a single pi. So if we look at it in terms of that and only consider the top half of the circle, then this point right here means 1/4 of the pi. So 1/4 times pi, or altogether it's just going to be pi over 4. Okay? If we move on to the next terminal side or the next point, this is going to be 2 pi over 4, right? 2 pieces of the pi over 4, which simplifies to pi over 2. And then here on the next terminal side, 3 pi over 4. And then here, 4 pi over 4. And what is 4 over 4? It just becomes pi, which is what we have here, right? 4 over 4, it's a 1. And so that's why we consider that as only the top part of the circle. Now, when we go on and talk about the rest of it, we continue counting like that. This is 1/5 of the pi over 4, right? This is the 5th section, the 6th, the 7th, and the 8th. So kind of look at it this way, right? This is what that number is telling us, right? Then there is 6 pi, 6 pi over 4, 7 pi over 4, and then this right here happens to be 8 pi over 4, which when you reduce it, it equals 2 pi. Okay, so we have now shown the different measurements of the angle, or how to come up with them in terms of radians, right? So pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and this is going in increments of 45 degrees. Okay, so that's the trick here, is that all of them are multiples of 45 degrees. Alright, just like the other example where we tried to show the different angle measurements, but in radians this time, here we have a little bit of a different circle, and this one has increments of 30 degrees included. So this one is 30 degrees. I'm going to skip this middle one, which is the same as the circle that we did in the previous example. Okay, this is just an overlap of the two, and then the rest is multiples of 30. Okay, so how do we do that? How do we come up with the radian measures for each of those angles without, actually multiplicating them by pi over 180 and then canceling stuff out? Same thing, right? This is 0 or 2 pi, and then this is pi. So we're going to think about the top part of the circle and just count. So how many times or how many different sections, equal sections, do we have? So this right here is 1. Ignoring that middle one, 2, 3, 4, 5, and 6. So therefore, our circle is broken into 6 different pieces on the top half. And so this point right here is pi over 6. This point right here is 2 pi over 6. This point right here, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then 6 pi over 6. Okay, simplifying, we get pi over 3. Pi over 2, and so on. Okay, some of them simplify, others don't. So if we keep going, this is 7 pi over 6. The next multiple of 30, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and if we go to the last little section, we get 12 pi over 6, and 12 pi over 6 is the same thing as 2 pi. So I suggest you actually given this an opportunity and do it on your own so that you understand where the numbers are coming from and how to recreate it on your own. This next section or piece of content is going to be about thinking in terms of radians, right? So if I tell you on the circle to go 1 revolution or 2 pi radians, it just means to go around the circle completely once. Okay, so 1 revolution around the circle, it just means to go from the initial side and then go around 2 pi, pretty much landing on the same spot. 3/4 of a revolution means what it means, right? Go 3/4 of the way on the circle. So if you do 3 over 4 times 2 pi, it simplifies down to 3 pi over 2, which is consistent with what we found when we were trying to populate the circle on the previous examples, right? Half of a revolution, half of the way around the circle. Well, 1/2 times 2 pi simplifies down to pi radians. Then, 1/4 of the revolution means 1/4 or 1/4 times 2 pi, which simplifies down to pi/2 radians. And then we've seen that already when we were doing the examples, filling in the radian measurements of the angles. So notice how those are all positive. So we could have essentially the same example here and have a circle in the middle here that we can use and say, well, I want to go -2 pi or negative revolutions. Okay, so if I think about that, that means that, no, I have the initial side here, but the circle is actually going in this direction, right? You go clockwise, and it's a negative number. Okay, so keep that in mind. Here on this second example, if I'm going and doing another revolution like this, then ¾ but in this case I'm going to do -3/4 of a revolution, then it comes down to -3 pi/2 radians. Then that means the following. I'm going in the opposite direction, so this last piece should be shaded black and not red. Okay, so I am going from here to here 3/4 of the way. Okay, then here I'll skip that and talk about the last example. And if I am doing -1/4 of a revolution, or -pi/2 radians, right? It just tells me that I'm going to start here and go this way, right? So from here to here, -1/4 of the whole circle. The next piece of information, we're going to talk about coterminal angles. And so the idea here with coterminal angles is kind of like what we've been talking about, that you can go in either direction, right? Whether positive or negative, we can end up in the same terminal side, right? That's the idea. So coterminal angles can be found in the following form. So either increasing or decreasing the angle, right, that you're given, the degree, measure, so when we say increase or decrease, right, we mean add or subtract the measurement, right, of a given angle by a multiple of 360 degrees, right? So this case we're talking about here is the case where we work with degrees, right? So if you are given an angle in degrees, then, and if you want to find the coterminal angle for it, you're going to add or subtract 360 degrees. Okay, so if you're given an angle theta, that angle is going to be coterminal with theta plus or minus 360 degrees times some number k, where k is an integer. Okay, so that's how we talk about incrementing a number in terms of some multiple, right? And so the same can be said for a radian angle. So the same right? So if your angle is given in radians or radian measure, right, all you have to do is increase or decrease, right? So increase the radian measure of an angle by a multiple of 2 pi, right? So then any angle theta, so theta plus or minus 2 pi k, right, where k is an integer. So that is how you figure out a coterminal angle to something that's given already to you. What does that mean? So let's look at a graphical explanation of what does it mean for something to be coterminal. So here's my XY coordinate axis, and then here is some angle, right? My terminal side is that, and then this is the initial side. So let's think, right? From here, from the initial side to the terminal, I'm going to say that there is 60 degrees. Okay, cool. But what happens if we say, well, the angle kept going and it stopped right there? So that has a measurement of 620 degrees. So how do you figure that out? Well, 60 plus 360, right? We went an extra revolution after we passed the 60-degree mark. So what we can say is that angles 420 degrees and 60 degrees are considered coterminal, right? I mean, they land on the same terminal angle, but they have different measurement, right? Keep in mind, one of them is over 360 degrees. They're both positive. We could be asked to come up with angles that are between 0 and 360, or we can come up with a negative version of it, and that's what we're about to do right now. So again, I have my initial side and then my terminal side in the blue. So what if I go and, by the way, having the terminal side here on the x-axis is considered standard form, right? So these two angles that I've shown you here, they are both in standard form. Okay, so going back to what we're saying, so both angles are in standard form, and this opens in the positive direction or counterclockwise direction, and has an angle measurement of 240 degrees, right? So, but what happens if instead of going counterclockwise, I go here clockwise direction? So this has a measurement of negative 120 degrees. So angles 240 degrees and negative 120 degrees are considered coterminal. Okay? And the same can be said about angles in radians. Okay? It's just the same idea. Okay? Okay. So the last piece of information that we have for this section is going to be figuring out the length of a circular arc. So as you can see in the picture, common picture that we have seen throughout the section is that we have an angle opening, we know the radius, and so this measurement in the red is going to be called S. That S is called the arc length, right? And so here's what we will need to know, I guess. Let R be the radius, of a circle, and theta, for now it'll be a non-negative value, so the non-negative radian measure of a central angle, right, of that circle. Then the arc length is given by this, S equals r theta, right? So the arc length is equals to the radius times the central angle, and keep in mind that the central angle must be in radians, okay? So in order to figure out the arc length, my radius, I'm sorry, not the radius, but the central angle must be in terms of radians, central angle in radians. And that concludes all the topics that we should cover for section 4.1.